simply the few problems, and most of them. I'm going to go back to question 1. So question 1, A, B, C. I did A in class. I'm just going to jump into B, 1B, sorry, this is 1B. 1, 2, 4, 7, 11. So here we just want the next two terms, right? That's simple enough. So we can see if there are patterns. All right, so from here, if we take the difference, it would be 1. This looks like a 2. This looks like a 3. And you'll definitely see a pattern, right? So from 11 to the next one, it will be a 5. So that gives us 16. And this, from 16 to the next one, will be a 6. So that gives us 22. One C, 2, 5, 10, 17, 26. There's a difference of 3 here, plus 3, plus 5, plus 7, plus 9, and obviously the next one's going to plus 11, which gives us our number of 37. We need that number, and we need one more, and then the other one is going to be plus 13, and that's going to take us to 40. Oh, 50, sorry. Okay. Question 2, we want to find the first 5 terms of each sequence. So if this represents that sequence, right? So we want the first term. So we can create a table. I don't know, whichever way you figure out it's more organized. So here's 1, 2, 3, 4, 5, the first 5 terms. So if I substitute, I get 1 squared plus 1, ends up being 2. 2 squared plus 2, which gives, 2 squared plus 1, which is 5. 3 squared plus 1, which is 10. 4 squared plus 1, which is 17, and 5 squared plus 1 is going to give me 26. So here are my first 5 numbers in that sequence. Okay. Second one is n squared plus 4, and again, you can create a table if you want to organize yourselves. So 1 squared plus 4, which is 5. 2 squared plus 4, which is 8. 3 squared plus 4, which is, sorry, I should have written 3 squared over here. 3 squared plus 4 is, I don't know, 9, 13. 4 squared plus 4 is 20. And then 5 squared plus 4, which is 29. And those are your numbers. And the first 5 numbers of this series, of the sequences, it's that. Okay, so again, pretty simple. Not exactly the ones I wanted you, but quite. So I think I did the first one. I'll do it again. So 4, 7, 12. There's definitely a lot of numbers here. I don't think we need that many, and I'm not going to write all of them. I don't need all those numbers. So the first difference looks like a 3, 5, 7, 9. It's definitely not linear, so it's second difference. You notice that it's 2, 2, 2. So it's going to be something n squared. Well, we're going to take that divided by 2, and our coefficient is going to be 1, so we don't really need to write it. So what does an n squared sequence look like? It looks like 1, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, and so forth, right? So we're going to subtract this sequence, this n squared, this quadratic, right? This n squared sequence from our original, and we get 3, 3, 3, 16, 19 minus 16 is 3, 28. Now, because they're all the same, we know we're going to stop right here, right? We don't need to take any more differences. So our final, in this case, is just n squared plus. Like I said in class, you might want to just plug in 5. So the 5th term of this sequence is 28. So if you plug in 5 over here, do you get 28? Well, 5 squared plus 3. That's 25 plus 3, right? Which is 28. So let's see, it works. I would always double check a couple more numbers. Okay. Just to be on the safe side. Second one, 51, 54, 59, and again, I'm not going to write all the numbers. 66, 75, That looks like a 3. This looks like a 6. No, what? 5. This looks like a 7. First difference. Sorry, I forgot to write it. That looks like a 9. It is. Not linear. Second difference tells me that this is quadratic. 2, 2, and 2. So again, it looks like n squared. The coefficient is going to be 1, so I'm not going to write that. So what does an n squared sequence looks like? It's 1 squared, which is 1. 2 squared, which is 4. 3 squared, which is 9. 4 squared, which is 16. And 5 squared, which is 25. We subtract, right? So we're going to get 51 minus 50 is 50. 54 minus 4 is 50. So notice that it's all 50, which means we're going to stop right here. So our rule here, yeah, right? Our rule here for this one is going to be that it's n squared. And how do I adjust this sequence to get me my original one? I add 50 to it. And plug in a few numbers, see if it works. Let's plug in the third, 3. So a third term should look like 50, should give us 59. So 3 squared plus 50 is 9 plus 50, and that gives me 59. Okay. Is that it? No, we have one more. So I don't think this is the handout that I really wanted, but it's okay. Negative 5 to negative 2 is plus 3. This is plus 5, plus 7, and I don't know why I'm writing the plus. But plus 7, 9, and 11. So, sorry, second difference. Right, it's going to get 2, 2, 2, and 2. It's quadratic, so divide 2 by 2, we get 1. We don't have to write that. And again, by now we know what an n square sequence looks like. It's just 1, 4, 9, 16, 25, 36. Let's subtract that. Right, so negative 5. And then here's where you have to be careful. It's negative 5 minus 1, which is negative 6. Negative 2 minus 4, which is negative 6. So be careful with that. So 3 minus 9 is negative 6. 10 minus 16 is negative 6. So notice that they're all negative 6. So they're all the same. We can stop right here. So our final rule here is n squared minus 6. So let me pick this 1, 2, 3, the sixth term. The sixth term tells me it's 30. Right? The sixth term of this sequence is 30. So if I substitute 6 over here, I get 6 squared minus 6, and that indeed gives me 30. So again, double check a couple more. That's what I would do. Okay, before just to confirm. N squared plus n. We want the first 5 terms. So again, this is just for you to get used to. And hopefully, well, I don't know about this week. Maybe this week, you'll notice that we can use this in graph, right? And you'll see what it looks like. So when n equals 1, we get 1 squared plus 1, and that gives us 2. When n equals 2, it's 2 squared plus 2, which is going to give us 6. When n equals 3, it's 3 squared plus 3, which is 12. 4, it would be 4 squared plus 4, which is 20. And then 5 would be 5 squared plus 5, which is 30. So, and then when we graph this, this would be our coordinates. 1 and 2, 2 and 6, 3 and 12. And then you'll really see that this is definitely not linear. Right? But for now, let's just stick to that. So our first 5 terms in this sequence is 2, 6, 12, 20, and 30. Right? I have no idea what I just did. Okay. So the next one is, again, n squared plus 2n. A little bit repetitive, no? Sorry. 1 squared plus 2 times 1, which is going to be 3. Sorry, let me write the square. So 2, when n equals 2 is 2 squared plus 2 times 2, which is going to be 4, 8. 3 would be 3 squared plus 2 times 3, which is 6, and 9 is 15. 4 would be 4 squared plus 2 times 4, which is 8 plus 16, which is 24. And finally 5. 5 squared plus 2 times 5, which is 10, 35. Okay, so there's our first 5 terms in that. Then we have n squared minus n. Okay. When n equals 1, right, our first term. 1 squared minus n, minus 1, so we get 0. When n equals 2, be 2 squared minus 2, which equals 2. 3 squared will be 3 squared minus 3, so we get 9 minus 3, which is 6. 4 would be 4 squared minus 4, 16 minus 4 is 12, and finally 5, our fifth term in this series would be 5 squared minus 5, which is 20. So there's my first 5 terms, 0, 2, 6, 12, and 20. So question 5, so I had a couple of questions here earlier today, so think about that. Oops. So when it's 1, we're going to substitute, and this is what it looks like, substitution. Substitution. So what are we taking to the second power? We're taking the value of n, and n in this case is just 1. So that is going to give me negative 1, right? 1 squared is 1, and then there's a minus sign there, it's negative 1. 2 is just 2 squared, which is 4, but because of a minus sign there, we get a negative 4. 3 would be 3 squared, and again, it would be negative 4, negative 16, and 5. 5 squared, which is going to be 25, and then as a negative gives us negative 25. The second one, and I'll maybe do it on the side, negative 2 n squared, negative 2 times n squared. Think about that. So 1 would be negative 2 times 1 to the second power. It's going to give us negative 2. 2 would be negative 2 times 2 to the second power. 2 to the second power is 4 times negative 2 is negative 8. 3 times would be negative 2 times 3 to the second power. 3 to the second power is 9 times negative 2 is negative 18. 4 would be negative 2 times 4 to the second power, so 16 times negative 2 is negative 32. And 5 is negative 2 times 5 to the second power, which gives us negative 20, not 30, negative 50. Okay, so a little careful there. Is that negative sign. So the last one, negative 4 squared. So negative 4 times n to the second power plus 2. We want the first 5. So when it's 1, it's negative 4 times 1 squared plus 2, which is 1 squared is 1 times negative 4 is negative 4 plus 2 is negative 2. When it's 2, it's negative 4 times 2 to the second power plus 2. 2 to the second power is 4. 4 times negative 4 is negative 16. Negative 16 plus 4 is negative 14. 3, negative 4 is third power is 9 times negative 4 is negative 36. Negative 36 plus 3 is negative 33. 4 would be negative 4, and then 4 to the fourth power plus 2. 4 to the second power is 16, right? 16 times 4 is 64, negative 64 plus 2, negative 62. And then 5 is negative 4 times 5 to the second power plus 2. 5 to the second power is 25. 25 times negative 4 is negative 100 plus 2, negative 98. All right, so a little bit of careful approach here when doing those.